9. So we remember learning about similarity last year. We've done congruency already, right? Do we remember what is happening with congruent triangles? If two triangles are congruent, they are equal, they're identical, right? They are exactly the same. They have the same sides and the same angles. For similarity, can anyone remember what similarity is? If two triangles are similar, what does that mean? Are they exactly the same? So all of their angles are the same, right, with similar triangles, but their sides don't have to be the same. Their sides will be in the same proportion. Okay, so that is what we have with similar triangles. So let's write here, triangles, wait, hang on, yeah, sorry. Triangles are similar if right, so one, their corresponding angles are equal. Or two, their corresponding sides are in proportion. So basically what that means, guys, is if we have two triangles and they have the exact same shape, but they can be different sizes. Okay, the angles of a triangle will influence the shape, right? Because remember, angles are where the two sides meet. Okay, so they have the same shape, they can have different sizes. So I'm just going to add here next to the heading, same shape, but can or let's say can be different sizes. Right, so I'm just going to draw an example quickly. You can just use a ruler. You don't have to draw it to scale. We are going to fill some values in. Right, so you can just draw a triangle there. And then we're going to draw a triangle with the exact same shape, but just a little bit bigger. Okay, maybe to see if you can make it twice the size. Like I said, you don't have to draw it exactly to scale. Just so that we can get an idea. Right, here we go. Sorry, just had to copy it. All right, so we're going to call the first one ABC and the second one DEF. Okay, I'm going to fill in some angles here. And again, don't worry if it doesn't look like the size of the angle that I'm going to write in. It's fine. It doesn't have to. We didn't draw them to scale, so don't worry about it. I'm going to say that, what's happening? Angle A looks almost like 90. Hey, let's say that one is 85. And then angle D will be the same size there. Angle C, let's say this one is 25 degrees. And then angle F will also be 25. Right, what is 85 plus 25? 110. So what does that mean? What will angle B be equal to? 70 degrees. Hey, remember, the three angles of a triangle add up to 180 degrees. Right, and E will then also be 70. I'm also going to fill in lengths of the sides. Again, it doesn't have to be perfect. I'm just kind of going to, make some values up here. Let's say that one is 3, and let's say this one is 7, and the other one, let's make this one, oh wait, actually I mustn't make it up. Did you already fill in a 7 there?
Yes, ma'am.
Okay, let me work out what the actual, oh wait, never mind. Let's make it, what do you guys think? Shall we go with a 6, I was going to say? Doesn't matter. And it's not accurate. Okay, I just want you guys to see how we would prove. So I'm going to make that one 6, and I'm going to make that one 12, and this one 14. Okay, don't worry about the accuracy of the values. We are just going to compare the two triangles essentially, all right? So guys, I'm hoping that you can tell that with these two triangles, we have the same 3 angles. Now, when they said, or when we wrote here at the top, their corresponding angles are equal, please don't get confused. I'm not talking about corresponding angles as in the sense of like the F shape, right? Remember when we worked with geometry earlier in the year, corresponding angles are angles that are in that F shape, right? What they mean with corresponding angles here is that in your two triangles, you have two angles that are the same. So we say that within triangle ABC and DEF, A and D are corresponding angles. Okay, it's the same angles in the two triangles. So they're not referring to F-shaped angles, just the same angles in the two triangles. So we have that angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. All right. So we can see that the first condition is met there. Their corresponding angles are equal. Now, guys, if you don't have any information about the sides, you only have information about the angles, that is enough to prove that two triangles are similar. Okay, so I'm going to write here, just like with congruency, do you guys remember we did a 5-line proof? We're going to do the same thing here. So to prove that triangle ABC and triangle DEF are similar, how many different ways were there to prove that two triangles are congruent? 4. Do you remember there were 4 cases? Side, 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 angle, angle, side, and right angle, hypotenuse, side. For similarity, it's very easy. There are only 2 ways. Angles or sides in proportion. Okay, you're never going to mix and match angles and sides like we did with congruency. So the first method is angles. And just like with congruency, we're going to lay it out in exactly the same way. We're going to say in triangle ABC and triangle DEF. And now you're going to list the angles that are equal. Angle A is equal to angle D. How do I know that? Given. It looks exactly like our congruency proofs. Second, angle B is equal to angle E. How do I know that? Given. Angle C, which was 25 degrees, is equal to angle F, also 25 degrees. That was also given. Guys, they might not give you all 3 pairs of angles. Okay, I very easily could have left out one of those 3 angles here. If we're looking at triangle ABC, for example, remember we actually filled in these two first, and then I asked you what is the size of B going to be? And then you said 70, right? So if we left out the size of B here, if that was not given, you could still calculate it. And if you had to do that, what would your reason be here? Instead of given, it would be angle sum in triangle. Okay, so just, it depends. If the information was given, like here, you will write given. If you had to actually calculate it, you would write that down. Therefore, triangle ABC. Now, guys, the symbol for congruent is 3 lines, 3 horizontal lines. For similar, it's 3 vertical lines, 3 parallel lines, essentially. Triangle DEF. Again, just like with congruency, you need to match up the angles that are equal, right? So I wrote it in this order, ABC. So I have to write it in the same order here, DEF. Okay, just like with congruency, we need to make sure that our angle A is written here first, so the angle that's equal to A needs to be written first there as well. Okay, the reason here is either angle, 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 or if you want to be fancy, you can write equiangular. Equiangular meaning they have equal angles. Okay, that's one method to prove that triangles are similar. And guys, this is the method that comes up most often. Okay, it's not actually, I would say maybe 1 out of 100 times are you going to be expected to use sides in proportion. We are going to do an example on that now. But that is the first way of proving that two triangles are similar. Second way is sides in proportion. Again, you're going to write in triangle ABC and triangle DEF. Now you're going to have to look at your triangles and identify the sides that are all going to be in a proportion. So I think for this one, it's very easy to see. If we're looking at the 3 lengths here and the 3 lengths there, you can check, okay, from 3 to 6, that's just doubled, right? Did the same thing happen here? From 7 to that side, 14, yes, that's also doubled. And then from 6 to 12 there, that's also doubled. Okay, so we are going to group these two sides together, 3 and 6. We're going to group those two sides together, and we are going to group those two sides together. Okay, sometimes they make it quite difficult by drawing the triangles in like a different orientation. And if they haven't given you any angles, I mean, it's easy to see here, right? So, for example, if you couldn't figure out which sides were kind of made bigger to get the other sides, you could just check, okay, BC is opposite 85. Which side here is opposite 85? 14. So those two must be in the same proportion. What about this one? 3 is opposite 25. Which side here is opposite 25? The side with the length of 6. All right, so you could do it like that. But if they didn't give you any of your angles, you're going to have to look at the 6 lengths, essentially, and figure out where the proportions are. You'll see. I'll show you an example so you can see what I mean. Now, what we're going to do here, guys, is we are going to say AB over DE is equal to, we're going to simplify, all right, to show what the proportion is with these two sides. Then we're going to take the two blue sides. BC over EF, 7 over 14, what's that equal to? 7 divided by 14 is a half, hey? And this one here, 3 divided by 6 is also a half. This one, 6 over 12, also a half. If you put your sides the other way around, you would get 2. Okay, which is also fine. So if you said DE over AB, 6 over 3, that's 2. All right, so you can go the other way around. You can decide, do you want to go smaller triangle over bigger triangle or bigger triangle over smaller triangle? It's up to you. Okay, you just can't mix them up. So I will write down both options for you so that you can see. All right, so the first one, let's say, what was that now again? AB over DE. Hello? That's fine, I know. AB over DE is equal to, you do unfortunately have to put in that middle step where you show the actual lengths. Okay, you can't go straight to a half. You have to write down every single step, and you have to write 3 over 6. I know it seems unnecessary, but remember these proofs are quite formal. Okay, we have to put down every single step, so that is equal to a half. Now we take another pair of sides. Let's do the blue ones on mine. So BC over EF is 7 over 14. And that is equal to a half as well. So you see we're getting a half, and now we must get a half for the third one to show that the sides are all in the same proportion. And then for the third pair, it will be AC over DF. And I think it was 6 over 12. Is that right? Thank you. So that is also equal to a half. So you have to get the same simplified answers here. Okay. But you also have to show which values you're subbing in. Yeah? No, for these ones you actually don't have to. But guys, let's do that actually, because yeah, if ever you're not sure whether you have to write given or not, just do it rather. Okay. For these ones, they actually don't take a mark off if you don't write given, but yeah, if you're not sure, rather write it down. Okay, so now we can see that the 3 pairs of sides are all in the same proportion, where the top side is a half the length of the bottom side. Right, does that make sense? AB is half the length of DE. AC at the bottom is half the length of DF, and BC is half the length of EF. All right, so the smaller triangle is half the size of the bigger one. Okay, so now we're going to say, therefore, triangle ABC is similar to triangle DEF. Now our reason is going to be sides in prop. Okay, you don't have to write proportion out. You are allowed to just write sides in prop. But for this, you can't write angle, angle, angle. Okay, if you've shown that all 3 pairs of angles are equal, you're going to write angle, angle, angle. If you've done this sides in proportion thing, you're going to write sides in prop. Just on the side here, I'm going to show if you did DE over AB, then you must say 6 over 3, and then you'll get equal to 2. That's fine. But then you have to do that all the way through. Then you have to put the bigger side on top for all of these. Okay, so you can't mix and match the black ones and the blue ones. All right, you must decide when you start, am I going to put the smaller one on top or the bigger one? Okay, and then do that for all 3 of your lines. Are there any questions so far, guys? Okay, that's basically it for proving similarity. So I'm going to give you an exercise now just to work on some of these questions.